General conveyor problems, we're going to look for excessive cover wear, potential carcass failures. Well, obviously, we're going to look at the splice joint. Why do you suppose that we're constantly making reference, as Mike did earlier, to either vulcanized or mechanical splice joint wear issues or fatigues? Why are we always going to the splice?
It's where it's visible.
There you go. It's where it's most visible. Now, I won't deny that in some cases, either mechanical fasteners or vulcanized splices can be the weakest link. I'm not suggesting that. But it's always a place where the belt's been disrupted to the point where you can visually inspect it. Everything else that might be going on with the fabric or the carcass or the structure of the belt is disguised. It's hidden. It's inside the belt. It may not represent itself in a visual manner. Slippage at the drive. How do we know if the belt's slipping or not? Maybe it's shut down and we don't have the benefit of seeing it running. Anybody got any ideas on how we know if the belt has been slipping? Lagging, the condition of the lagging. What else?
Bottom side of the belt.
What would it look like?
Shiny or wore out.
Okay, he's saying that the bottom side of the belt might be shiny or worn out. Does anybody disagree with that? Absolutely. It's called glazing. The compound of the bottom of the rubber, if it has been heated up, and you've heard Mike make reference to chemical change, okay? If you add heat to that belt to the point where it might even start smoking or squealing or whatever, because of slippage, you'll see that bottom cover, you might even see cracks in it, you'll see a real shiny sheen to it, and it'll be hard. Well, if you have slippage issues, all those things can represent themselves by that bottom cover changing chemistry as a result of heat being introduced to it and slippage.
Sometimes too, the lagging rubber will actually revert, and you'll see it on your troughing cans.
What do you mean when you say revert?
It's where it actually reverts back, starts to decompose, and reverts back to its natural state, loses all its properties. So as it comes back around, being that it's on the driven side, you'll find that rubber deposited on the top of your troughing cans up and along the system. A lot of times guys will think that it's the belt itself, breaking down and whatnot. You'll find in lagging there's a lot of various compounds out there, some good, some bad. And in most cases when you get slipping like that, if your bottom of your belt itself is glazed over from the heat, but you're noticing rubber deposits throughout your system on the troughing cans, it's more than likely due to the rubber on the lagging reverting.
Great point. I appreciate your input on that, Joe. You know, once again, as Darrell alluded to earlier this morning, the story's in the cans. You know, we talked about where the paint fatigue is as a result of maybe the belt being under compression, poor transition distance. Well, if there's rubber deposited on it, but you don't see any missing rubber from the bottom, could very well be exactly what Joe is talking about. It's a reversion of the lagging material. Excessive cover wear can be caused by improper loading. Wear patterns on our belt can tell you if it's improper loading or not when the belt's shut down. You can see it right away if the belt's running, correct? Everybody got a good handle on proper and improper loading? We didn't really tackle it, but it's pretty safe to say you want the belt, ideally you want the product moving at about the same speed as the receiving belt, and you want it centered in the belt. You get those two things cooking, and you're doing all right. Improper would be anything outside of that, but obviously varying degrees of impropriety. It happens all the time. I mean, especially in aggregate, you see all kinds of belts that are side loading at a belt that's going 90 degrees another direction. Well, that's going to happen. But they can still figure out ways to center it if they have their geometry where it needs to be. Material trapped in the system. We touched on this. Tail pulleys that are winged have material trapped in it, build up on other pulleys that are in the system. Where else might we have trapped material? Anything we didn't cover on that? Any ideas?
All your junctions on your troffer.
Yeah, a good point. Yeah, you got the three clustered troughing idlers. You have idler junctions there from the flat to the trough. You don't want any material in there. It'll play hell with the idler and with the belt. Sorry, please? Chutes getting plugged up. Daryl loves that. Get that stuff built up right to the belt, and then have the belt run inside its own material and just tear itself up.
Rocks in between the donut rollers,
Yeah, okay, donut rollers being the return idlers that are segmented.
even the ones on top even sometimes.
Yeah, impact idlers, yeah. You want to look for, that's not where you want material to be.
Anything you're handling on that belt will find a place to stick and take the covers off the belt, which is why I'm in the business. But so when you do an inspection of your system, look in all those little nooks and crannies. And if you look at your belt and you start seeing a strange wear pattern, then follow that wear pattern to its source and get rid of it, because it'll just keep eating until it eats the carcass up, destroys the belt.
A lot of times with mechanical fasteners, those types of fatigue issues will represent themselves quicker or more quickly than they would on the rest of the belt, just by looking at the wear pattern on the splice, on the mechanical splice. Incorrect skirt board materials and installation. Let's talk about incorrect skirting. Who here would like to take a stab at, and probably knows, what would be an incorrect material to use for skirting? Go ahead, Del. How many people here know customers who use conveyor belt for skirting? Let's see a show of hands. That's pretty good. Daryl, you like people that use, love them. The proper skirting material, without getting into too much detail, you want the skirting material to be softer than the rubber compound of the belt that's under it. 45, 60 durometer, usually, that's a pretty good range.
Typically, belt cover stock will be in the 60 to 65 range when it's brand new. So anything below that point is considered a good chance of saving your belt covers.
Why do we want the softness of that rubber to be softer than the top cover of the belt? So the skirting will fatigue before the belt will. What's more expensive, the belt or the skirting? Duh. Okay. What about incorrect installation of skirting? What do you suppose we're going with on that? Too tight? That's a big one. Too loose, become ineffective, material spill out, contaminate the whole staging area. Anything else? What about the angle of the skirting? Is there a good angle, bad angle? What is the belting specification, belting manufacturer's ideas on the angle at 90 degrees versus at a similar angle to the trough?
Basically, we like to see it lie inside, so that the surface of the belt and the surface of the skirt board is actually interfacing in this manner instead of straight down. Give more chance of getting something trapped here, get more chance of wear. So if you can spread that wear area out, then that's better for both.
It creates
you
a
and
better
us.
seal, and you have more surface area of skirting to fatigue before it becomes ineffective.
The only thing I think we look at too is the difference between straight and angled. It also depends on what you're conveying on your belts. I mean, typically hard rock mining, when it's coming out of a primary crusher, you can get away with using straight. Straight down without coming in on an angle.
And that's
A
because
lot of that has to do with the material that's being conveyed. I mean, there's not one that's better than the other. It's what we talked about before, misapplication.
There you go.
And one of the most important things from anybody skirting is everybody realizes that the rubber, whosever rubber you're using, and whether it's angled or straight, is not made to contain the conveyed material. It's made to catch the fines. You need some kind of internal squirt burr in there to keep your load contained, either being an angled plate, straight plate, wear plate, AR, whatever you want. If you're asking anybody's rubber to contain your load, it's not going to work for you.
And it's going to fatigue out just lickety-split. Improperly installed belt cleaners. They use the right terminology here. What do you suppose happens with improperly installed belt cleaners?
One could be too much tension on the cleaner.
And
on
what's
the head.
going to happen if it's over tension?
You're gonna put in too much more force on the belt. You're gonna use more horsepower and amps. Nobody likes that. You're gonna wear out your cover and the cleaner blade. It could get hung up, especially on mechanical slices, vulcanized. Wrong cleaner blade on the wrong type of belt, wrong material. There's a lot of chances for a lot of people make a lot of different mistakes in putting the cleaners in. A lot of bad stuff.
Yeah.
Rocks, big rocks get stuck in there for your big 8-inch minus.
Yeah. Yeah, that'd be a problem, wouldn't it? And then, of course, we have the little thing called the angle of attack, especially on cleaners that are right on the head pulley. And it's important that you follow the manufacturer's, or the customer follows the manufacturer's specifications for where that cleaner actually contacts that belt at that location on the head pulley.
Because we get a lot of calls, we being manufacturers of belt, and the guy says, your cover's no good, and you go out and look at it, and right down the center of the belt, you got a chatter mark, full length of the belt, and it really doesn't bother anything, except for he gets really upsided when he's got that carryback problem. But that happens if you put those cleaners in the wrong place on that pulley. It'll set up a chatter, and every time that blade comes down, it'll put a little chip in the cover stock. And after a period of time, it gets big enough that it really becomes a problem. But if you happen to be Ash Grove Cement and you're carrying 400 tons of cement up the conveyor and 200 tons back, it's very significant to you.
Many pre-cleaners that go on head pulleys, the location of the pull to the shaft of the head pulley is what's critical. That's what the point of reference is. And it gets violated every day, usually by when the end user installs it himself, and he says, here, Joe, go put this on, and they might even put it in a hole where the old cleaner was, and the old one was a homemade cleaner or whatever. It's going to lose efficiency significantly. And if you can get a working knowledge of where they're supposed to be located, which is not terribly difficult to do, talk to your preferred cleaner manufacturer guy, then you can get a quick feel if the head cleaner's where it's supposed to be or not. What happens to the belt when the tail transitions are too short? It goes into compression. Okay? Compression, bad. Unless, of course, you're Darrell. Compression's good then, because he'll sell you more belt. Improper loading. Ideally, material introduced to the belt should be flowing in the same direction as the belt travel and at roughly the same speed as the belt is running. Happens every day, doesn't it? Not. Particularly in the aggregate industry. They cobble these conveyors together, and as long as stuff's not going on the floor or on the ground, it's working. That's all they care about. Until they start seeing accelerated fatigue factors, either in the belt, components, drive systems, other things like that. And that's where all of us troubleshooters are going to be able to go out there and say, hey, if you were to move this here and that here and elevate this just a little bit, a lot of this other stuff would go away. Now you're gaining equity with your account. Product conveyed should be loaded in the center of the belt. Most people know this. Those same people that know this are going to violate it. It could be something as simple as making sure a deflecting plate in a chute is actually directing the material correctly. They don't want to change the chute because that would require additional effort. They've moved the conveyors. Okay, it worked before, it should work now. But now maybe it's side loading the belt. That'll represent itself in all kinds of problems and issues. Transfer areas. The takeaway belt should be running at least 15% faster than the loading belt and be capable of handling slightly more material. Transfer areas should be free of obstructions and allow for the conveyed product to flow smoothly. You know, how many times you see a conveyor system running and it might be near empty, and then here comes the front end loader dumping stuff into the crusher or the screener or whatever the heck it's dumping it into. Now all of a sudden the belt, bango, it's full. Okay? Suppose there's any shock loading going on with that belt when all that stuff hits it? Absolutely. Raining, snowing, hot, cold, all those types of factors. But you might want to look at and see how the product is flowing through the conveyor, not only if it's centering it, but if it's restricting it. Maybe there's something stuck in it. And if it is stuck, that's a symptom of what's going to be the solution. Here's a couple of illustrations of loading. Thing I like about this one is dribble chute. How many times you see this? Nice to have though, isn't it? Because even the belt cleaners that are on there, or belt wipers that are on there, there's going to be some renegade material that escapes it, even though it might not be adhering to the belt. It'll sort of turbulate off the back of the cleaner blade. The dribble chute will pick it up and direct it back into the product flow. So that might be a recommendation for housekeeping issues that a customer's having. Hey, you ever consider putting a dribble chute on back here? You see here, it says that the bottom of the chute is 2/3 the width of the receiving belt. That's another one of those idealisms. I don't think anybody actually goes out of their way to make it wider than the receiving belt, but they darn sure will stick a belt under there that may be 30 inches and still be 36. Then you want to inspect the skirting and make sure it's containing the product. Loading concerns. There's on-center loading. This is pretty severe. You can see the belt tracking clear off the idler set. Avoid trapped material. That's another thing that I guess I didn't bring up about skirting that you want to inspect. It's not that the material can just get trapped under the skirting material, but it can actually get trapped in the structure where the skirting is supposed to be. You see that this, what I would guess would be skirt board rubber here, and here's the structure. Well, that rock got in between the actual skirting material and the structure, and there you have it. And there's another illustration of trapped material and return idlers. Be careful with skirt board. Never use conveyor belt skirt board. Only use skirt board that's softer than your belt cover. Adjust skirt board near covers, not into covers. If more rigidity is required in skirt board use, thicker material, not harder material. There's a good one. Okay. Ensure proper clearance of frame from belt. Skirt board installation. Here we have different examples of how the skirting might be used. Belt cleaners must be installed per manufacturer's directions, maintained to ensure metal frame does not come into contact with the belt, must have proper pressure, and must have proper blades. If not in use, should be removed from the system. Well, these are all idealisms. We already talked about manufacturer specs for where the cleaner should be located. We also need to be able to verify the amount of tension that you have on a cleaner onto a belt. Again, refer to the manufacturer's specifications on it. Overtension can be just as problematic and maybe even more so than being undertensioned. Undertension is not necessarily going to be damaging a belt. If a cleaner is overtensioned, you get back to the chatter marks, you can have all kinds of things going wrong with the belt that's not going to improve efficiency. What's important for you to know is the rock guy rule of thumb is that if the belt cleaner is not cleaning, you crank down on it until it starts cleaning again. And you need to be aware of that state of mind when you go looking at belt cleaners or thinking that the belt cleaner is part of the problem, that could be going on. Carcass failure. Earlier today, Mike referred to the fabric in the belt, the skim coats in the belt, the adhesive materials. Collectively, all that stuff is referred to as a carcass. Okay? You might have 2-ply belt, that'd still be the carcass. 3-ply layers of fabric, skim coats, adhesions are referred to as the carcass. So in a belt, you got the carcass materials, and then you got the bottom cover and the top cover. Okay? So when this refers to carcass failure, we're looking at issues that may cause the fatigue or the failure of the material in the belt due to impact, material trapping, buildup in the system. Pulley diameters are too small. Okay? As tensions increase, operating tensions increase, and that percentage of the relationship between rated tension and operating tension. You know, Darrell was talking about most belts operating between 30 and 60% of the belt's rated tension, but you're going to get those guys out there who are going to operate at 85, 90% and not take into account any shock loading issues. As that operating tension increases, the minimum pulley diameter needed for this to properly flex and travel increases. And, correct me if I'm wrong here, transition distance needs increase. So it's a bad deal if you're operating above, really, if you're operating above 85% of the belt's rated tension, you're gonna, unless everything's just smooth and consistent, you're gonna accelerate belt fatigue and life real quick. Drive changes are the changes in the load. S drives with close set crown pulleys. Crown pulleys are designed for what? Keeping the belt centered, right? If we have an S drive, which I think in this case is alluding to having a tandem drive, so you got two pulleys driving a belt, it's going to go through an S configuration. You want to make damn good and sure that those crowns are aligned with each other. You know, there are other issues with S drives, making absolute sure that they're running at the same rotational speed, because if you have one running slower than the other, you're going to have a real problem in between them. Excessive take-up weight. We've already talked about that and how it'll over-tension a belt. And transition distance is too short. Impact. Care should be taken to reduce impact on the belt by whatever means possible. A lot of times impact beds are designed not so much solely for impact, but for product containment. Because at the staging area of the belt, where that stuff's coming onto a belt, you're creating that shock load right there and then at that immediate moment. And the belt's taking the impact or the weight of the material that's being introduced to it. Impact beds will have a means to dissipate all the pressure that's being exerted at the time, at the point where that material is weighing down on the belt over a larger area. If you just had idlers there, then you'd have the idler taking the brunt and then the space in between the next idler taking it. So impact beds have a way of facilitating product containment as well as assisting with the actual, it'll protect the belt because it'll give it support when this stuff's coming down on it. Here's an illustration of what they call impact idlers. These are usually some sort of a material that has ability to be able to flex. In this case, I'd say these are rubber disc type impact idlers. And this illustration over here shows you how the impact is taken in the center idler when the rock drops down on the belt. And that protects the cut and gouge of the actual belt itself by being able to take that energy absorption.